Hi and welcome back to another lecture in computer science for everyone. This time we're going to talk about creating a list, because the queue and other data structures we're going to be creating are going to be based on a list. So we need to create the list first, and then we'll be able to create the queue. This is going to be a fairly long and complicated lecture, so if there's something that you don't understand, go ahead and ask a question. However, understand that some content cannot be explained just theoretically in a presentation. So please watch this video and then the programming exercise. And after that, if there's something you don't fully understand, go ahead and ask the questions. Okay, so what we're going to be creating is called a linked list, which you might have heard before. A linked list is just a sequence of items where each item is not fully independent. Each item just knows where the next item in the list is. This means that each of the items in the list has what we call a pointer. So it points to the location in our computer's memory where the following item in the list is stored. This lets us go from one item to the next very quickly without having to, for example, look in memory or things like that. So this is the idea behind a linked list. Let's imagine we're creating a linked list of students where each of the elements holds name, matriculation number, and year of study for each student. Just like so. So we have the name and matriculation number as two strings, and then the year of study as an integer, and finally we have a next node. You might have noticed that the class name, which is node and in green at the top, is the same data type as the next variable. So indeed, the next variable that is here is of type node, just like the node itself. We'll see how this works when we're programming. So we'd have something like this. One node that is George and has that matriculation number and is in second year. And then it has a next node that points to Anna. So Anna is the next node of George. And Anna's next node is Philip. So as you can see, we only need a reference to the first node, which is George, and then we can go to all the other nodes by just following the list. Finally, Philip's next node is not another node, it is null. Null in Java is a keyword that means nothing. So here, because Philip is the end of the list, the next node is null. So how could we implement this linked list? We're going to need two classes. One to store the data, which is the node, stores the data and the next node, and another one which is the list. The list is going to manage the nodes, adding new nodes to the list and finding a node in the list, for example. And also is going to hold the first node, because if each node points to the next one, then there is no node to point to the first one. This is why our list class exists as well, in order to hold this reference to the first node in the list. So the list class has methods to find a node in the list, for which we need to supply the student name, and add a new node at the beginning of the list. So it would be like so. We have this list, we have the head, which initially points to null, because initially the list is empty, so there is no nodes, so this head is null. And then we have the add to list, which takes a node as a parameter, which is going to add to the list. And then find, which takes a string as a parameter, which is going to find in the list, looking through the students, which node matches the string we're looking for. So which student name in the node matches the string we're looking for. And then we have that. So essentially what this is going to do, this head is one of these nodes. Initially it is null because there is no node. Add to list is going to take one of these nodes as a parameter, and it's going to add it to the list. We'll see how we do that in a second. And then find is going to take a string, and it's going to go through the list, matching this string to all the names, and if it finds the correct one, it will print the details out or do something about it. So the add to list method is going to take a node as a parameter, as we've seen. And then it's going to do one of two things. If the head is null, this means our list is empty. We will make the head of the list, which is null, equal to the new node that we're adding. This, I think, makes sense because we don't have any items in the list, so we simply make the new node equal to the first item. If the list is not empty, it gets a bit more complicated. We will put this node at the beginning of the list by making the new node the head of the list, just as we've done. However, we will make the new node point to what used to be the head of the list, effectively putting this node in between the list and the head. I'll show you what I mean with a graphical example that I think will be easier to understand. So we have our list, which is this, and the head initially points to null. And then we call the add_to_list method and we give it a node. This creates the first node by making the head, instead of point to null, point to this new node that we've added. So this is now the head. And then we call this method again. What happens is that the current head is going to move, and this variable is going to point to the new node, like so. So this head now points to the new node, and the new node now points to the old head. If we added more nodes, or we simply move this one down, this one here, and we would pop the new one in right here. So the head would point to the newest node, and then the newest node would point to the previous newest node, and so on and so on. Like so. Okay, so how would we program this add_to_list method? If the head is null, we set the head to be equal to the new node. Else, we make the new node point to the head. Let's see what I mean with this. If the head is null, we make the head equal to the new node. As we have seen, this is because the head was previously null, didn't point to anything, our list was empty. Now we want to add the new item, so we make the head, which is the first element of the queue, equal to the node we're adding. If not, we're going to make the new node point to the current head, which is the first item in the queue. And then we're going to make the head equal to the new node. This new node keeps pointing to the old head when we run this. So this points to the first element, and then we change the first element to be the new node. Once again, we have our list. The head initially points to null. Then we have our two methods, add_to_list, which takes a node as a parameter, and find, which takes a string as a parameter. We call the add_to_list method, and this creates our new first node. Head, which pointed to null before, now points to the newest node. And then we call this method again. What is going to happen is that we're going to make the new node we're going to add point to the current head, and then we're going to change the head to be equal to the new node, like so. So actually, this arrow is created first. This node points to the head, and then we change this arrow here. Because once we've changed this arrow, once we change the head to be Anna, we've lost this head, unless we point from here to the head beforehand. This is why we make this node point to the head, and then the head point to this node. If we made the head point to this node first, then nothing would be pointing to this node, and we wouldn't know how to point to it. We'd lose it. And that is what happens when we're deleting a node. We simply make nothing point to it, and then Java realizes nothing is pointing to it, so it just deletes it from the memory. Java is brilliant for this sort of thing. So we create a new node, and it points to the previous head, and then we change the head to be equal to the new node. Okay? So how would we find a node? The find method is fairly simple. We go through all the items in our list, we iterate through our list, and we'll see how we do that in a second. It's fairly simple. And if any node has the same student name as the one we're looking for, then we print the details out. So we have this list we call find Anna. So we're going to find Anna in this list. We know it's the element number 1 or the second element in this list. And then what's going to happen is that we're going to go to the first node. We're going to check the head. Is the head's name equal to Anna? We're going to find it is not. So then we're going to go to the next one. And then we're going to check again. Is this node's name Anna? We're going to find it is. And then we're going to print Anna 3324515P and 3. So that's everything that this method is going to do. Let's see how we could program this. Just like in our for loops, we needed to create an index variable that would essentially hold the position, or how many iterations of the loop we had done so far. Here we need to create a marker node that will keep track of in which node of the list we are. So first of all, we create the marker node. I'm sorry, those words weren't meant to come from the titles, but hope that's okay. So we create the marker node and make it equal to the head, because we're going to start searching this list from the beginning. While the marker is not null, for example, in the first iteration, this would mean the head is not null, and therefore the list is not empty. So while the marker is not null, we're going to see if the marker node's name equals the name we're looking for, and that we gave our method in here. We do that by comparing the marker's name to the parameter. If marker.getName dot equals the name we gave it. Remember, we don't compare strings with 2 equal signs. And then if it does, we just printed node's details out, like so. Obviously, this makes many assumptions of the design of the node, but don't worry, because in the next video, well, actually in the next couple of videos, we're going to be going over how to create the node, the list class, and also another one that's going to let us run the program and do some funny stuff with it. Okay, so after we've done all of this, we created a marker, we've made the marker equal to the head, we've checked if it's null. If it's not, we check if the name equals the name we're looking for, and if it is, we print the details out. But we're never changing the marker, so this is always going to check the head. So what we have to do is we have to make the marker equal to the next item of the list. If the marker is the head, marker.getNext is the second item in the list, because marker.getNext is the same as head.getNext. So the next item after head is what then gets assigned to marker. Hopefully this wasn't too confusing, but if it was, let's go into the next lecture. We're going to actually program that. And I think that with the programming and seeing the program's output and everything, it will help you understand, get a bit more comfortable with how this is working. So stick with me and let's go into the next video where we're going to program the node, and then in the following one we're going to program the list, and finally another extra class that will let us perform more functions with the list. So stick with me and let's go into the next few videos.